Math! Hey everybody, this is Mr. Regner, and it's once again time for the Aftermath, where today we are focused on focus for week number 10. So we're going to take a look at our week 10 day 2 activity, or 10.2. Feel free to follow along at home as we complete our work here in the video. Let's check it out. Number 1 says an expression is shown, 7 times 7 times 7. Which choice below is equivalent? So a couple things here for number 1. First, we're talking about the word equivalent, which means equal, the same. It's the same as the other thing. And so I have 7 times 7 times 7. All of my answer choices give me exponential notation. So I simply want to answer this by thinking about what my base would be and what my exponent would be. So let me go to my paper here and show you how this will work. So here I am, and there's not a whole lot of work that I can do necessarily, but I can make little check marks and show that there are 3 7s in this problem. With that in mind, I know squared means 2, and I know cubed means 3. 3 to the 7th, and then 7 times 3 are my options. This means I'm taking 7 multiplied by itself 3 times, so my answer is B. So number 1, pretty easy problem for us to figure out. Not a whole lot of work involved either, but it's really important that we understand exponents. Let's move on and take a look at number 2. Number 2 says, on Saturday, a minor league baseball team gave away baseball cards to each person entering the stadium. One group received 24 baseball cards. A second group received 102 baseball cards. If each person entering the stadium received the same number of cards, what is the maximum number of baseball cards that each person could have received? So for this one, I really want to interpret the problem and understand what's happening. So cards are going out over here, cards are going out over here. There's 2 different amounts, and so I want to compare both amounts and try to figure out what is the greatest number that goes into both of those amounts. So if you're thinking about that, you're probably thinking greatest common factor, and that's indeed what we're doing. So let's go ahead and take a look at it here on our paper. All right, so here's the problem once again. And once again, I'm looking at 24 baseball cards in one group, 102 in the other. Again, it says the maximum number of baseball cards if we're talking about the same number. And so that we think is greatest common factor. So in order to do this, I simply create some factors, and that all involves factor trees, finding prime factorization. So I'm going to make a factor tree for 24 and a factor tree for 102. So away we go. And again, your factor tree may look different than mine, but in the end, we're going to get the same prime factors, and that's what's most important. So I'll take 2 times 12. 2 is a prime number. 12 is composite. 2 times 6 equals 12. 2 is a prime number. 6 is composite. 2 and 3, both of which are primes. All right, so we move my paper up so that way you can actually see it. That's always helpful. Okay, so if I list out my prime factors here for 24, I could say 24 is equal to 2 times 2 times 2 times 3. And then for 102, now there's a couple ways that I could think of this. I'm going to go ahead and split it in half because I know that 2 means that it's even, and so 2 goes into it. So I'll say 2, which is prime, times, and that would be 51. Now 51 is actually composite. So I want to think to myself carefully, what goes into 51? Okay, if we follow our divisibility rules, I could take my numbers, add them up, and the sum of those digits, if it's divisible by 3, I know that 51 is divisible by 3. So 5 plus 1 is 6. 6 is divisible by 3. Therefore, 51 is. I'll say 3 times 17. Now, both of those numbers are prime. So I'll say 102 is equal to 2 times 3 times 17. So now, just switching colors for the video purposes here, I'm going to go ahead and circle the common primes. There's a 2 there, and there's a 3 there. There's no other common primes. So I would say that the GCF, or the greatest common factor, is going to be equal to 2 times 3. I know that 2 times 3 is equal to 6. But I'm not done yet. I want to, of course, include a label. And since we're asking what is the maximum number of baseball cards that each person could receive, I'll say it's 6 baseball cards. And there we have it. There's our answer for number 2. All right, so we've worked through these problems, and we are now rolling right along to number 3. So let's check it out. So number 3 says, what greatest common factor should be used to reduce the fraction 88 over 121 to simplest form? So this is a great practical use of why we find the greatest common factor. If I have a big giant number like this fraction and I want to simplify it, I could be spending a lot of time simplifying and then reducing again and reducing again and reducing again. If I just simply find the greatest common factor between the two numbers, my numerator and denominator, I can just simplify by dividing them both by that number once, and I know I'm as simple as I can go. I've reduced it as much as I can. So let's take a look at it. We're once again finding the greatest common factor. In fact, it tells us right there in the question, greatest common factor. So I'm going to go ahead and write out 88 and 121 because I'm going to create some factor trees. So 88, I'm going to take kind of the simple route here and say 8 times 11. Now 11 is a prime number and 8 is composite. So 8 breaks down into 2 times 4. 2 is prime, 4 is composite. 4 breaks down into 2 times 2, both of which are primes. So I'm going to say that 88 is equal to 2 times 2 times 2 times 11. And then 121, that may be a fact that you guys just know. It may be a fact that you really struggle with, but you should probably get to know that 121 is a perfect square. That means it's the answer of a number squared, and that number is 11, because 11 times 11 equals 121. Now 11 is a prime number, so I'll say 121 is equal to 11 times 11. So once again, I'm going to circle for myself any of the common primes in that prime factorization, and it happens to be 11. So the greatest common factor is equal to 11. Now I'm not multiplying 11 times 11 or writing it twice, just once for each grouping that I have. So there's my answer. No other label is necessary for number 3. All right, so there's a look at number 3. Again, numbers 2 and 3, you're doing the same work. It's just finding the greatest common factor. You're going to get a lot of practice with that this week, so it's something you'll definitely want to use as we work on our focus quiz. Right now, let's roll ahead and take a look at number 4. Number 4 says, which of these whole numbers are not less than 4/3 to the third power divided by 1/2 to the second power? Okay, so in order to answer this question, we first have to answer that expression. So we want to think about bases and exponents, how those things work. I'm going to write this out in expanded form to take out any exponents, and from there, I'm just multiplying some numbers together. Let's go ahead and get to work. All right, so here I am on my paper. I'm going to go ahead and write this out with parentheses. So I have 4/3 times 4/3 times 4/3. And you might say, why did you write it 3 times? I wrote it 3 times because of that exponent. All right, and then it's going to be divided by 1/2 to the power of 2, or squared. So that's going to be 1/2 times 1/2. All right, so now I can just go ahead and multiply straight across, because that's how I deal with fractions. That's 4 times 4. 4 times 4 is 16. And then 16 times 4 is going to equal 64. Some of you might know that in your heads, or you might work it out off to the side. Either way, we're going to come up with the same answer. And then I have 3 times 3, which is 9. 9 times 3, which is 27. So this whole thing, which is 4/3 to the third power, equals 64/27. All right, that's going to be divided by 1/2 times 1/2. Now 1 times 1 equals 1. And then 2 times 2 equals 4. All right, so I have 64/27 divided by 1/4. This is really just a simple division problem with fractions. And whenever I think about this, I always think of 3 big letters. I'm going to write them right over this in my highlighter pen. Keep, change, flip. I hope that's turning up for you in the video, because we're going to keep 64/27. I'm going to change my sign to multiplication, and then flip or use the reciprocal of my second fraction. So now I have 64/27 times 4/1. Now the first thing I would do is probably look to see if I can cross simplify, and I would soon find out that I can't cross simplify. So I have 64 times 4. I don't know what that is off the top of my head, so I'm going to do this off to the side. Okay, so I've got 256, so that means this is equal to 256, and then 27 times 1, I can do that in my head, that's 27. So now I have an improper fraction, 256 over 27. The only way that I can do this is to divide. So I'm going to set this up kind of like right here, with 256 being here, 27 is my divisor. So how many times does 27 go into 2? It doesn't. 27 into 25, it doesn't. 27 into 256, this is where I need to guess and check. And so my first guess here is going to be a 9. And I just happen to know that this is correct, so I'm not doing any work off to the side. But 9 times 27, I don't know what that is. I'm going to have to do this math here on the paper. So 9 times 27. And I get 243. So I'm going to subtract now. That's 3, that's 1, that's 0. So I can take this 27, combine it here with my 13. The 27 becomes my denominator. The 13 becomes my numerator. All right, so if I look at this here, this is the answer to my problem. In other words, I'm going to go back up to the question here. And by the way, if you're thinking, wow, he just did a whole bunch of work, you're right, I did. This right here is the same now as 9 and 13 27ths. So I'm just going to write that in here. Another issue that you may have with this is the language that's used in the question. It says, which of these whole numbers are not less than 9 and 13 27ths? It might be simpler to take out the not less and replace that with the word greater. Or even bigger might be a better way of phrasing it for you. Whatever is going to make the most sense. So now I just ask myself that question. Is 11 greater than 9 and 13 27ths? I would say, yes, it is. Is 10 greater than 9 and 13 27ths? Why, yes. Yes, it is. Is 9 greater than 9 and 13 27ths? I'd say, no, it's not. And 8 would not be, and 7 and 6 and 0, those would all be smaller. They would be less than 9 and 13 27ths. So there you see for number 4, definitely a lot of work went into it, but we broke it down, made it all pretty much simple as far as, is this number bigger or smaller than the answer that we got? So remember, know about exponents. We need that for numbers 1 and 4. Know about greatest common factor. We use that for numbers 2 and 3. And then just be prepared for some basic computation like we completed in number 4. That's our look at Focus this week. I'm Mr. Regner, and this has been The Aftermath.
Math! Aftermath, it's the aftermath. Aftermath, it's the aftermath. Math class is fun, but when it's done, stay in the zone. On your own, it's math review, made just for you. Take a video wherever you go. Aftermath, it's the aftermath. Aftermath, it's the aftermath. Oh yeah.